This video works through some of the problems that we saw on the handout from section 6.2, and we did some of these in class, so these are correlated with the slides for the sections that are posted. But this is a handout. If you don't have it, it's posted online, and so I thought I'd take the chance to go through and do a video showing some of the solutions of these problems, so that you can refer back to it as you come across the same kind of problems on the homework that you're doing. In the first group of problems on the left side here, we're answering questions about f of x, and of course that's just a matter of understanding the notation is telling us to do. So for example, f of 5 means that we want to use 5 as an input into f and then see what output we get. And the key here is that this picture that we see is a graph of f. So there's only one function that's being shown here, and it's f of x. So f of 5 means we find 5 as an x-coordinate, and we go down and read off the y-coordinate. It looks like it's about negative 5.5. That one's not on a nice whole number, so I'll say approximately negative 5.5 to hedge my bets. The second question asks what's f of 0, and so again that means that x is 0, and I'm reading down here and seeing the y-coordinate, and it looks like the y is about negative 3.5. And f of negative 6 means I run to my x-coordinate negative 6 up to my y-coordinate. Oh, that's actually a whole number, finally. So f of negative 6 looks like it's about 5. All right, so so questions about f inverse, the most important thing to realize is that's not the same function. So f inverse is another function that is related to f. And so my recommendation for how to answer questions about f inverse is to think of the question as really an equation. We want to think of it as an equation that says f inverse of 5 equals what? And the what is the question mark. And the reason we want to do that is because the inverse relationship between f and f inverse means that an equation involving one of those functions is equivalent to an equation involving the other function. The only difference is that the inputs and outputs are swapped. So this question about this equation f inverse of 5 equals what is exactly equivalent to the equation f of what equals 5. So the input and output are swapped because I've changed from f inverse to f. So because those functions are inverses of each other, it means their inputs and outputs are swapped. So the key is this question is a question about f, and so we can answer that question using our picture. In terms of f, this question is saying, the question up here is saying, what input gives me an output of 5? So in terms of the graph, remember the output is the y-coordinate. I'm looking for a y-coordinate 5 and saying, what is the input that gives me that? And the answer is negative 6. Notice that that is written right there. So we already knew that f of negative 6 was 5, so in a sense, at that point, I could have said, oh yeah, and also I know that f inverse of 5 equals 6. And so that would also be true for either one of these. It'd be easy to write down another statement that uses the f inverse. Okay, so if we treat each of those that way, then I can take the equation f inverse of 0 equals what, and say that's equivalent to f of what equals 0. Now that means on the f function, find a y-coordinate of 0, so that's here, and read off the x-coordinate, which would be negative 3. So negative 3 is going to be the value of f inverse of 0, specifically because f of negative 3 is equal to 0. And then finally, f inverse of negative 6 equals question mark is equivalent to f of what equals negative 6. And so again, on my graph, that means I'm looking for an output of negative 6, which happens when the input is 6. So the answer is that a 6 could go here, and so therefore this answer is 6. All right, so if we wanted to draw a graph of that, which is what it says in number 2, keep in mind that every point that I've just plotted on the right side here, I mean every value that I found on the right side is really a point that I could plot. So on the F inverse graph, we should see the point 5, -6. That's what B tells us. So 5, -6 is a point there. The second point, D, tells us that 0, -3 is on the graph. And F tells us that the point -6, 6, which I have smartly written on top of, oh well, it's up there, -6, 6 is up there. And so those are 3 points that I have. Keep in mind that the F inverse graph comes from the F graph by swapping all of the points. And so the way this one's drawn, because it's made up of little line segments that go through nice whole number points, I can plot a few more. So for example, the F graph has this point on it, point 2, -4. So -4, 2 is going to be on the F inverse graph. Let's see what else. This point is at -2, -3. And so at -3, -2, I will have the mirror image of that point. What else? This is the point -4, 3, and so the inverse graph is going to have the point 3, -4. And up here is the point -6, 5, and so our inverse graph is going to have the point 5, oh I said that, 5, -6, right? And so those are the sort of corner points, the sort of zigzaggy points, and so I should be able just to kind of draw the thing that goes through those like that. That's not very good. It's not very straight. But the idea is that it should look like a mirror image of the original about this dashed line. So that dashed line is all the points where the y and x coordinates are equal. And so about that line, it should look like my graph is a mirror image of the original. And if I could draw better with this pen, if I could draw straight lines, it wouldn't be that hard to do. Anyway, so in the second part, the one on the left, the 1/2 x minus 3, that's the one we did in class. So I thought in this video I would just do the same thing with the one on the right, so that if you did work on it on your own, you'd be able to check your answer. So so it says we want to sketch the graph of g of x. I'm going to draw it over here on this side. And it's the graph 4 minus 3/2 x. So I know how to do this with lines. I know that I basically just find intercepts. So the point 0, 4 is definitely on here. You could put in other values of x. I'd put in even values. Those are easier to evaluate. So if you put in x equals 2, you get y equals 1. That. If you put in x equals 4, you get y equals -2. That. And so every time we go, so the slope's -3/2, so every time I go over 2, I'm going down 3. So that's about as good as I can do. So my line will look like that, if that really was a line. Holy crap. I can't undo. Oh well, that's as good as I can do. So anyway, it should be a line that actually hit those points. Drawing the graph of F inverse, the other part of this is easy because for every point that I just plotted, I could plot the reversed point instead. So instead of the point 2, 1 on the inverse, that would be the point 1, 2. Instead of the point 0, 4 on the inverse, it would be 4, 0. Instead of the point 6, what did I say, 6, -5. Yeah, so instead of the point 6, -5, it would be the point -5, 6 here. So that's the mirror image of that point. And so if you draw a few of those on there, you'll see that basically what's happening is that your slope, instead of being -3/2, is -2/3, because the role of input and output have been swapped. So 1, 2, 3, 1, 2, 3, like that. So again, I'll try to draw this, but be prepared. So like that. So this is the original g of x, and so this guy is the graph of G inverse of x. Now, because I can plot those points exactly, even though I can't draw my line on it, and it's a line, I could find the equation for G inverse of x just by finding the equation of the line through two of those points, because I have a whole bunch of points on it. Oh, I should say also that here's the dashed line, the little mirror image line that happens. Again, that's all the points, well, it's supposed to be, all the points where the y and x coordinate are equal. So anyway, so those two graphs look like mirror images of each other across that line. But one thing we went over in class, which I think is valuable, if you're not working with a graph, is that it is possible to find the algebraic formula for one of these things just by going through a couple of steps. And so remember, the steps were these. We first want to write the equation of the formula for the function. Instead of using function notation, we want to use our x and y notation. And the reason for that is that the x and y notation highlight the role of the x and y coordinates in the graph. So this literally, the x and the y in this equation are literally x and y coordinates on the picture. So, so by using this form, we'll be able to use our intuition about what the inverse means. The second step is to solve for x. And this step is maybe not so clear why you do it, but when you see step 3, you'll see why. So if I solve this for x, that means I'm going to get the x by itself. So my first step might be to get the 3/2 x on one side and all the other stuff on the other side, and then I'll multiply both sides by 2/3. And so I'll have x equals 2/3 of 4 is 8/3, and 2/3 of y is just 2/3 of y. So that's solving for x. And then step 3, and this is where the inverse actually happens, is switch x and y in this equation. So what I mean by that is literally change the x to a y and the y to an x. So that equation that I just wrote down that I put a box around, if I switch x and y, it looks like this. And that's the equation of the G inverse line. And so if I want to write that in function notation, which is how it's asked, I would just rewrite that as G inverse of x equals 8/3 minus 2/3 x. That's my inverse. It's very easy to check because I have a whole boatload of points up here that I've plotted. So for example, on the inverse curve, I said that well, God only knows what this is because I missed the point so badly with my line. We said when x was 4, y was 0. Pretty sure I drew that one pretty close. So when x is 4, y is 0. If you check, if you put x equals 4 in here, you get y equals 0. Right? So this really does go through those points and have the correct slope. So that process works to find algebraic formulas for inverses, and the only step that's hard is solve for x. Right? We didn't really do any work anywhere else. Everything else was just conceptual. So as long as the equation we have originally can be solved for x, so we know enough algebra to solve it for x, then we actually can find the inverse formula. And we'll see that sometimes we do have enough algebra tools to solve an equation for x, and sometimes you don't. But when you do, when you are able to solve for x, then you can find the formula for the inverse.